Hi everyone. So this video is going to cover part of lesson 1.6. Now technically the topic for lesson 1.6 is choosing a good display. And so really a main focus in this section is just comparing the different types of data displays. When is one beneficial over another, that kind of thing. We've sort of talked about that as we've learned about the different types of data displays. A lot of it is kind of instinctual. So I don't know that we necessarily need to sit and talk through all of these different data displays and their strengths and weaknesses. It is here, it's written here, so if you would like to pause the video and write all of these down, you are welcome to, but I don't think you necessarily need to. There's really only one part of this lesson that I think is super critical. So I would like to look at this first example here where we talk about rate of change. So let's start with our definition of rate of change, okay? When I give you this definition, and especially when I write it down in symbols, I think you're going to recognize it as something else. I think you're going to notice that it's something that you've learned before, and I'm going to kind of talk to you about the real tiny clarification we need to make between this and another concept that you know. But definition for rate of change is change in the dependent variable compared to one unit of change of the independent variable. So just to remind you, the dependent variable we typically call y, and the independent variable we typically call x. So the change in the dependent variable means I'm picking two values of the dependent variable. I'm just using this as my example. So picking two of these and finding the difference or the change between them. Essentially, I'm taking y2 and subtracting y1. Okay? Per, which we know means division, the change in the independent variables that go along with that. So divided by x2 minus x1. Okay, so this right here is the formula for rate of change. But I hope that your brain is screaming at you, hey, wait a second, I already know that formula. You have learned that formula before as slope, right? That's the slope formula, and you've been doing those forever. So what's the difference? What is the difference between slope and rate of change? To clarify, slope is actually a very specific type of rate of change, okay? Slope is a rate of change for a linear function, and a linear function's rate of change is constant. It never changes, okay? That's why it gets its own special name. It's the slope. So on a linear function, it doesn't matter which two y values you pick, or which two coordinates you pick, I should say. You're always going to find the same slope. That's not true for every function, and that's not true in statistics necessarily. So you're not going to have a constant rate of change. What this gives you is the average change, or the average amount that the y value is changing per one of the x values in that span of time, or between those 2 points, I guess I should say. So we're going to do a calculation of rate of change using this table here. This is prices of gold in dollars per ounce between 1975 and 1995. So the first question is rate of change between 1985 and 1990. So looking at these two. This is my x, this is my y. So the first thing I'm going to do is y2 minus y1, so 385 minus 318 over x2 minus x1, so that would be 1990 minus 1985. Now I'm going to talk through the pieces of this calculation because I think that'll make it so that your final answer is a little more meaningful. So when I do 385 minus 318, let's see, I'm going to get 75. I believe I'm going to get 67. I hope that I'm right. If that's a mental math fail, I apologize. And then we're dividing by 5. So that 67 is really saying how much did we grow? From 318 to 385, we increased by 67 over a span of 5 years. Okay, so we increased by $67 over the course of 5 years. Dividing this then, let's see, 67 divided by 5 is going to be 13.4. That's my rate of change. What that means is that the price, which is my dependent variable, increased because it's positive. Oh, I should say increased on average. The on average part is important. by $13.40 per year. So from 1985 to 1990, on average, every year my price increased by $13.40. Now, I don't know that it necessarily went up by exactly that amount every year. That's what the on average part is talking about. Maybe it increased a lot from 1985 to 1986 and then didn't increase as much moving forward. But on average, we could say it's about $13.40 a year. Okay, so now let's look at the same thing between 1985 and 1995. And this is actually a little bit interesting because 1995 is exactly the same, right? It's 385. So it's 385 minus 318, which is still a difference of 67. But now this is over a span of 10 years. So 1995 minus 1985. That's a difference of 10 years. And so my rate of change there is 6.7. So I would say the price increased on average $6.70 per year. The reason for the difference is now we're covering a span of 10 years and not 5 years. Okay, but if you actually look at what happened here, this wasn't just steadily increasing at a rate of $6.70. There's actually some places where it went down. See, it decreased here, and then jumped back up again here. So when we give an average rate of change, we're really kind of glossing over the ins and outs of what happened and just saying, hey, on average, if we just drew a straight line between these 2 points, this is what we would see happening. Essentially, that's what you need to know today, is that when I say find the rate of change, I'm telling you to find the slope between 2 data points, okay? And what that slope is meant to represent is what's happening on average to your y values for every one of whatever your x values are, which is typically a unit of time. A lot of the times it's a unit of time, okay? That's really it for today. If you can find rate of change, you are good to go for lesson 1-6. So rate of change, make sure you've got that formula written down, and you've got a few homework problems to try that go along with this. All right, have a great day.